Hello students, welcome to today's physics lecture. In this session, we are going to understand the basic concepts of physics in a very simple and clear way. These ideas form the foundation of physics and help us understand how objects behave in our daily life. Let us begin with physics itself. Physics is the branch of science that studies matter, energy, space, time, and the interactions between them. From the motion of a bicycle to the flow of electricity, everything around us can be explained using physics. It helps us understand both natural and man-made phenomena. Now let us talk about matter. Matter is anything that has mass and occupies space. Everything we can see, touch, or feel, such as air, water, soil, books, and our own body, is made of matter. Matter exists in different forms like solids, liquids, and gases. Closely related to matter is mass. Mass is the amount of matter present in an object. It tells us how heavy an object actually is. An important point to remember is that mass does not change from place to place. Whether an object is on Earth or on the Moon, its mass remains the same. Next comes weight. Weight is the gravitational force acting on a body due to the Earth. Unlike mass, weight depends on gravity. That is why a person weighs less on the Moon than on Earth, even though the mass remains unchanged. Now let us understand motion-related terms. Distance is the total length of the path traveled by an object, irrespective of direction. It only tells us how much ground is covered. For example, if you walk around a park and return to the same point, the distance traveled is the full path you walked. On the other hand, displacement is the shortest straight-line distance between the initial and final positions of an object in a given direction. Displacement depends on direction and can be zero even when distance is not zero. To describe how fast an object moves, we use speed. Speed is the distance traveled by an object per unit time. It tells us only how fast something is moving, not the direction of motion. When speed is combined with direction, it becomes velocity. Velocity is the displacement per unit time in a specified direction. Any change in speed or direction results in a change in velocity. Now let us discuss acceleration. Acceleration is the rate of change of velocity with respect to time. An object accelerates not only when its speed increases, but also when its speed decreases or its direction changes. An object is said to be at rest if its position does not change with time with respect to its surroundings. For example, a book kept on a table is at rest relative to the table. If the position of an object changes with time, the object is said to be in motion. A moving car, a flying bird, or flowing water are all examples of motion. Physical quantities are divided into two types. A scalar quantity is a physical quantity that has only magnitude and no direction. Examples include mass, distance, speed, and time. A vector quantity, on the other hand, has both magnitude and direction. Displacement, velocity, acceleration, and force are vector quantities. Direction plays an important role in vector quantities. When an object covers equal distances in equal intervals of time, it is said to be in uniform motion. In uniform motion, the speed of the object remains constant. If an object covers unequal distances in equal intervals of time, the motion is called non-uniform motion. Most objects in real life move with non-uniform motion. Now let us understand inertia. Inertia is the tendency of a body to resist any change in its state of rest or motion. A heavy object has more inertia than a light object. This concept was explained by Newton's first law of motion. Next is momentum. Momentum is the product of mass and velocity of a body. An object with greater mass or higher velocity has more momentum. Momentum helps us understand collisions and motion. To change the motion or shape of an object, we need force. Force is a push or a pull that can change the state of rest, motion, direction, or shape of a body. Pushing a door or kicking a ball are examples of force. When more than one force acts on an object, the combined effect is called net force. Net force is the vector sum of all the forces acting on a body. It determines whether the object will accelerate or not. Finally, let us understand balanced forces. Balanced forces are equal in magnitude and opposite in direction. They do not change the state of motion of a body. An object under balanced forces either remains at rest or continues moving with uniform velocity. Conclusion: these basic physics concepts are the building blocks for understanding advanced topics. A strong grip on these fundamentals will help you perform well in school exams, competitive exams like IIT-JEE and NEET, and also understand real-life situations better.